you need to remember the correct graph will be first ionization. Oh, sorry about it. Okay, so first ionization energy graph will be comes like it's starting from here, then go straightly up
Then go
and then go down. Then only there will be two
two
breakages,
breaks.
right? So here we have
Yes,
hydrogen, here it's helium, lithium,
lithium,
beryllium.
beryllium,
So there is no
boron.
any elements coming in between lithium or beryllium, right? So after lithium, the
Yes,
beryllium
sir.
has to be in this point, not in the middle.
Yeah. Yes, sir.
We have to be very careful where we have to put the element in the middle. It's not here. It's on the starting from here, right? So lithium,
Yes,
beryllium,
sir.
and boron. Then
Boron,
carbon should be
carbon in the
in the
middle.
like it should be in somewhere in this line, but we need to be very careful where that element will come. The carbon will be coming. It should have more than beryllium. It should have first ionization energy more
Beryllium,
than beryllium. So it has to be
beryllium.
somewhere here. And nitrogen will be here. And when you are drawing oxygen, the oxygen will have more energy than carbon.
Carbon
So the graph will be not going for that far.
down.
It will be somewhere like this and go up again. Then only you will have the oxygen more than having more energy
Carbon,
than the carbon. So
carbon.
oxygen will come here and fluorine and neon. And you need to be very careful. Always helium should be at the top. Helium
Top.
is the one who is having the highest, highest
Higher
well,
ionization energy.
ionization energy. Correct? So this is the
Yes, sir.
graph shape you need to remember, and then you will know if it is involving third period also, who will be here instead of lithium. The graph shape would be same. Graph shape would be same. It will go down here, and we have to put instead of lithium, who will be coming here at this point? Sodium, right?
Sodium. Yes,
And
yes, sir.
instead of beryllium, who will be there? Sodium. Next to sodium, it's
Magnesium.
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 And here again, aluminium. Likewise, it will go on, right? You get it?
Yes, sir.
Okay. So you don't
Okay.
have to
Yes.
think that much about this one because the graph questions would be not coming that much difficult. They will only ask the basic questions from here. Okay. So you don't have to worry too much
Okay.
about this. So the reason we have studied this graph is why? Because we know there are two characteristics we have to see when it comes to a periodic table. One is first ionization energy and the other one is electronegativity, right?
Negativity. Yes,
So
sir.
the problem with first ionization energy is it will not change accordingly. It will not change uniformly,
Accordingly.
right? But
Yes.
electronegativity is kind of a uniform. There is a uniform pattern, correct? So when you
Yes,
take
sir.
periodic table, here hydrogen, here helium and lithium, beryllium, boron, like this it will go and again like this, and there will be two another elements. So in this direction, how electronegativity will change? It will uniformly
Decrease.
this way,
Increases.
electronegativity
Uniformly increases.
increases,
Uniformly
uniformly
increases.
increases. Who? Electronegativity
Negativity.
increases. And in this direction, if something is increasing in this direction, the same characteristic should be the same uh, characteristic that we study. Electronegativity will what happen? It
Decrease.
will
Decrease.
decrease. So there will be a totally opposite relationship when it comes to period wise and the group-wise. From up
Group
to
wise.
down, and left to
Down.
right, there is total
Right.
opposite behaving pattern, right? Right.
Yes, sir.
So that is about the electronegativity. It will happen uniformly. But first ionization was not like that. First ionization is something that will decrease uniformly from up to down. In the group wise, it will behave like what? It will behave like electronegativity. Uniformly, what happened? First ionization energy.
Decrease.
It will
Uniformly
decrease
decreases.
uniformly. Unlike group wise, from left to right, the problem, there is where the problem comes, right? That's where the problem
Yes, sir.
comes. Because there you cannot observe a uniformly changing pattern. Somewhere it will increase and then suddenly decreases and increases and decreases. So that kind of a behavioral change you can see when it comes to first ionization energy, correct?
Yes, sir.
So that's why we want to what memorize this graph.
Graph.
Now you get it, right? We are not going to
Yes.
study any graph for what? Electronegativity, because there is not
Negativity.
need, because it is behaving in a uniform manner. So we don't need to know any graph to say this one is greater than this one, right? Okay.
Yes, sir.
So let's study more like in detail about electronegativity. Okay. So
Okay.
electronegativity is basically it is related with ionic bonds or covalent bond.
Covalent bond.
It is related to covalent bond. So we know
Covalent bond.
if it is a covalent bond, to form a covalent bond, the atoms need to what they have
Share
what
the
they
elect.
have to do? They have to share the electrons.
Share the
Unlike
electron.
ionic bonds, where you will see losing and accepting, here you will see what?
Accepting elect.
Sharing of
Sharing
electrons, right?
electrons.
So when it comes to
Yes, sir.
sharing, there only we can discuss about what? Electronegativity,
Negativity.
right? So let's take a simple example here. I'm saying there is an atom called A and there is an atom called B, right?
Okay, yes, sir.
I am indicating the electron of this Ba as cross. That is one electron of B. And I will indicate with dot for A. Now, if I tell you they are going to create a compound like this, they are going to create a compound like this by sharing one electron each. Okay, that
Yes,
is
sir.
how the AB is formed. That's what I am saying. Okay, now
Yes, sir.
if they are sharing, they need to put the electrons somewhere in between them. He is not going to keep this dot with himself. He is not going to keep this cross electron with himself. They need to be shared. They need to be put in between those two atoms, correct?
Yes, sir.
Now the problem, here is where our electronegativity comes. Now, when they share the electron, this electron pair is called as what? That's a pair of shared electrons, correct? That's
Yes,
a
sir.
pair of shared electron.
Electron.
So this shared electron, the ownership, uh, which one is belong? Like which one this shared electron is belong to? The ownership belong to?
A.
The ownership will be belong to both of them because they are shared electron,
They
right?
are sharing. Both of them are sharing. So
Both
both.
of them
Okay.
are sharing. So there is a special name called for this. There's a pair of shared electron, right?
Yes, sir.
Right. And if I am drawing some electron here and some electron here, now if I ask you, how many electrons A is having? Total electron of A.
4.
4. 1, 2, 3, 4.
3,
So when you are
4.
counting
Yeah.
for A, you need to count the shared electron as his electron, right? So it will come for the count,
Yes, sir.
and this will be somehow, it will always come because it's a, this pair is only belong to A, not for, right, not shared, right? So when I
Not for B.
ask you
Yes,
like
yes, sir.
how many electrons for B in total, how many electron B is having?
3 electrons.
It is having 3
3
electrons.
electrons. Sir.
This one and these two. So now you understand the basic, right? Now I am telling you electronegativity. How electronegativity comes into play when it comes to this kind of a situation is, I told you the shared electron has to be staying somewhere in between A and B. But this electronegativity
B.
of the atom is the what decide atom. So each atom is going to have electronegativity, right? Some amount of electronegativity. So electronegativity basically means the ability to what? The ability to attract the which electron?
Electron.
Shared electron, not
Shared
just
electron.
electron, shared electron. So if someone is having more electronegativity, the ability to attract the shared electron is also what? High. Correct?
Yes, sir.
So ability is what? Called as electronegativity. Ability to what? Ability to
Electronegativity.
attract the shared electrons.
Attract the shared electron.
So now tell me, if I tell you B is having more electronegativity than A, tell me when I draw the same diagram here, where I need to point out the shared electron. If I tell you the electronegativity of B is greater than electronegativity is of A. Now tell me where I need to draw this paired, shared electron, this pair of shared electrons.
Near to B.
Near to B. Very good. Near to B. It is not belong to B. It is still belong to both of them. Okay? That shared electron is
Okay.
still a shared electron. That is still belonging to both of them. Only difference
Both
is
of them.
instead of staying in the middle, the shared electron will go little bit closer to
Yeah.
what? Will be going little bit
Close
closer
to the B.
to B. So that's the only
B.
difference it will make, the electronegativity. Okay? Right. So
Okay.
this is a like kind of a, this is not real element. So when if I give you an example for real element, let's say between C and O, carbon monoxide, kind of a gas is forming, and tell me if they are making a kind of a pair, and how many shared electrons here?
4.
There are 4 shared electron. How many pairs of shared electron?
2 pairs of shared electron.
2 pairs. Okay, right. Now tell me, by understanding this definition, and you already know how electronegativity behaves in the periodic table. You already know that. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen,
Yes.
oxygen, kind of
Lithium.
oxygen, fluorine, neon,
Boron.
right? So
Yeah.
now tell me, what are the 2 atoms we are
Neon.
talking about?
Yes, sir.
Carbon and oxygen. Now you tell me, where I need to
Oxygen.
write this pair of shared electrons? Near to who?
Near to oxygen.
Near to oxygen. The reason is,
The electronegativity uniformly increases.
yes, electronegativity uniformly increases from left to right So
Right.
oxygen is in the right side of carbon. So eventually the oxygen will be having what? More electronegativity than carbon. So
Yes.
when we are drawing the shared electron, it should be drawn near to who? Near to
Near to oxygen.
oxygen, not in the
Oxygen.
middle or not near to the carbon. It has to be close to oxygen. Correct?
Oxygen.
So this is the
Yes.
basic things you need to know about electronegativity. There is only one thing we need to discuss on this electronegativity. That is simple. Now tell me, Regine, in this
Yes.
example, in this example, I told you if B is having more electronegativity than B, so than A, that pair will be close to B, right?
Yes.
Right. So tell me, these electrons are moving towards B, moving away from A. Now tell me,
A.
uh, this is kind of a thing. Now moving things are having what charge? They are having negative charges because they are electrons. So if electron is
Yeah. Yes.
coming closer to B will be
Yes, sir.
B will be having a smaller effect of this electron. So this electron, by getting closer to B, it will give smaller amount of negative charge to who? Negative charge to
To B.
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 So to indicate, it is a little amount. It is a little amount, not a
Little.
big amount. We are putting which sign? This kind of a delta minus sign. So this sign indicates it's not kind of a complete minus. It's a small little amount of negative. That's why it's kind of a,
Minor. Yeah.
we are putting this kind of a uh, code, right?
Sign.
This kind of a
Okay.
symbol, right? So you don't necessarily need to remember this symbol. What you need to know is they will ask you in the exams what are the charges you need to give for A and B. You need to write either plus or minus. Now tell me, what are you going to write here? You will
Okay.
write directly minus. Here you will write plus.
Minor.
Why you are writing plus here?
Plus.
Because these electrons are moving away from A. Moving away means we can take it as
A.
it's kind of losing it, right? It's not actually losing, but it's kind of little similar
Yeah.
to what? Losing, because it is going
Kind.
away from the
Losing.
whatever the atom, right? So here you need to put
Yes.
positive sign, correct? Okay, you understand? Now tell me,
Okay.
for this one,
Yes, sir.
what is the charge you are going to put here and what is the charge you are going to put here?
For C plus.
And for O minus. So what
For
is the
minor.
last note we have written in the text? What we have written in the notes?
We draw the graph and write the heading electronegativity.
Right. So under electronegativity, you write this definition first. The ability to
Okay. Okay, sir.
did you write the full definition? Ability to
Yes, sir.
right.
Attract the shared electrons.
It's like the shared electron. After that, right. Oh, oh. After that, right. This example,
Okay.
A and B are putting the electrons each, and the shared electron comes, and the shared electrons will be going closer to B, going closer to B. Don't write this sign for now. Going towards B. So write this in an order.
Okay, sir. Written, sir. Sir, I wrote, sir.
Right? Okay. So after that, you need to write somewhere here mention this is happening like this because mention electronegativity of B is greater than
A.
electronegativity of A. That is why it is moving towards B. Right?
Okay, sir.
So this is kind of a light I'm using. So you have written this and this is fine. Okay. Then you need to write a real example. Okay. Now under that, after that, write this point. In a covalent bond, in a covalent bond, in a covalent bond,
Yes, sir.
in a covalent bond, the atom who has more who has more
Electronegativity.
electronegativity will get little amount of what?
Minus.
Minus. And other atom inside the brackets low electronegativity will get little amount of what?
Plus. Sir.
Little amount of positive, right? Little
Yes, sir.
amount of positive, correct?
Yes, sir.
Okay. After writing this,
Yes, sir.
write this example. Let's say for water, H2O, it is kind of a having covalent bond. So when it comes to H2O, right? We will study how to draw this. You don't have to know like why we are writing in this angle. So it's because of the way they are sharing the electrons. So these things, these are called as Lewis. This is the structure we are studying under Lewis structure. Okay, Lewis structure.
Yeah. Okay.
Did you study in this school? So it's in the 10th chapter, no? It's
We
in the
study, sir.
10th chapter. You studied, right? So this is what called as what?
Yes, sir. Low structure.
Lewis structure. Okay. So if I write like this, okay, let's say, like this. And if they have given you a question like this in the exam and give you some brackets over here and asking you to put the positive and negative sign, how are you going to put it? For that, you need to know what? You need to know how they are arranged in the periodic table, right? So if it is
Yes,
hydrogen, helium,
yes, sir.
lithium, beryllium, boron, carbon, nitrogen, oxygen,
Helium,
fluorine,
boron,
yeah, if they are going like that,
oxygen.
now you know hydrogen is somewhere here and oxygen is somewhere here.
Yeah.
So who is more to the right? So you know
Oxygen.
when you go downwards, the electronegativity will decrease. That's correct.
Electronegativity decrease.
Decrease. In this way, it will
Yes, sir.
increase. So we cannot take just because the decrease is here, you cannot say oxygen is having low electronegativity than hydrogen. Why? It will be correct regime if you say lithium is having low electronegativity than who?
Hydrogen.
Hydrogen. That is correct. Then why this is wrong? You cannot say that to oxygen. Why?
It is not under the.
No, because the reason is regime, you just see here, hydrogen and lithium, they are in the same group, right?
Yes, sir.
And
Group
lithium
one.
is right below the hydrogen. There is no any chance
Yeah.
for lithium, there is no any chance for lithium to increase his electronegativity. But regime, when you go this way,
Yeah.
even though there is a small amount here, if I say this is 2.5 and lithium is having 2, okay, when you go in this
Yes, sir.
direction regime, it will increase more than 2.8, okay,
2.8. Yes, sir.
because in this
Yeah, sir.
direction it will increase. So the increase of this
Increase.
direction is very much high than the drop in here, than the small drop here. You understand?
Yeah. Okay, sir.
So lithium is getting 2 because there is no any chance to lithium to increase his electronegativity. But for oxygen, it can increase the electronegativity by going in this way. He is very much in the right side. So when you go in the right side, it will automatically what? The decrease amount will come back again.
Yes, sir.
Right? You understand it right now. Okay?
Yeah, sir.
So now tell me, what is the plus and minus sign we have to put? So with this one, you can
H will
understand
be plus.
oxygen is having a high electronegativity
Yeah.
because that is in the right side. Hydrogen is in the left. That is the reason. Okay?
Yes, sir.
Right.
Okay.
So the higher electronegativity, it will get minus. So this oxygen also minus, and this will be Plus.
Plus.
So you need to write entire thing.
Okay.
Finished?
Yes, sir.
Now let's study about chemical formulas. Okay, how to write chemical formulas.